So the final section that we are going over before the end of this semester is probability. Probability is the chance of an event occurring. And it's written in the notation P for probability and then the event that we want to happen in parentheses. So if I am flipping a coin and I want to find the probability that it will land heads up. So I would write this in notation probability of heads, and it would be 1/2 because there's only one side on the coin that is heads, but there are two sides on a total coin. So the top number is the possibility of it happening. The bottom number is total numbers of events that could happen. So if I take a look at number 2, it wants me to find the probability that I land on a space that is even. 2, 4, and 6 are all even. There's 3 even spaces, total of 7 spaces. So my probability here is 3/7. Okay. Number 3 is talking about a single dice. Dice has 6 sides, in case you forgot. Okay, so 6 sides. Each of them are numbered 1 through 5. On this one, it wants me to find the probability of landing on just 5. There's only one side like that, so it's 1/6. For B, it wants me to find the probability of a number less than 5. So that's 1, 2, 3, 4, not 5, because it doesn't say less than or equal to 5. So I have 4/6 possibilities. I can simplify this fraction. It turns into 2/3. An odd number. Those are numbers like 1, 3, and 5. There's 3 of those. So this simplifies to 1/2. Okay. On number 4, it's telling me a card is drawn from an ordinary deck, and I gave you a sample space just in case you didn't know what an ordinary deck of cards has in it. So there's 52 total cards. There's 4 suits, heart, diamonds, spades, and clubs. And then the cards are numbered A, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then Jack, Queen, King. So A is typically called an ace, Jack, Queen, King. This one is hearts, diamonds, spades, clubs. It wants me to find the probability of drawing a jack. There are 4 jacks and 52 total cards. So what I want to do is I want to simplify this. On my calculator, remember, if I clear my screen, I can do 4 divided by 52. And then if I go math, choice 1 is fraction. I press enter and it simplifies the fraction for me. It's 1/13. Okay. It wants me to write the probability as a decimal to the nearest thousandth. So if I go back and look at this, I have 0, remember it goes tenths, hundredths, thousandths. So the 6 is what I need to go up to. It's going to round into a 7 because the 9 after it. So it's 0.077. To turn it into a percent, I want to multiply it by 100. Which gives me 7.7%. And it wants it to the nearest tenth, which this one is. Okay. Next problem says, if I randomly select a letter from the phrase rain is awesome, what is the probability I select a consonant? A consonant, remember, is not a vowel. So it's all the other letters. I need to figure out how many letters are in this phrase. There's 1, 2, 3, 4 for the word rain, 2 for the word is, 1, 2, 3, 4, 5, 6, 7 for the word awesome. So there are 13 total letters. Okay. And then I need to figure out how many of them are consonants. So I'll write those in red. There are 2 in the word rain, 1 in the word is, 1, 2, 3, 4 in the word awesome. So 2 plus 1 is 3, plus 4 is 7 consonants. So what I want to do is I want to take that and just write it as a fraction, 7/13. Okay. Number 6 is telling me I have a bag. It has 3 blue marbles, 5 green marbles, and 17 yellow marbles. I want to find the probability that it's green. So I need to add 3, 5, and 17. 8 plus 17 is 25, so I have 25 total marbles. I know that 5 are green, so I have 5/25, which simplifies to 1/5. Okay. Number 7 gives me this chart. It tells me a local high school is polling students on whether they're planning or going to prom or not, and the results are listed below. We're assuming that they were not surveyed this year. We want to figure out the probability that the randomly selected student is a junior. So what I want to do is, if I look at this chart, junior is this entire row. There are 106 total juniors, and there are 220 total students. So I have 106 students out of 220. That is even over even, so I can simplify. 106 divided by 220 is, math fraction, 53/110. It wants me to figure out the probability that a randomly selected student is a senior who is not attending. I'm going to highlight this phrase in yellow and then go highlight it up again in the chart. So I want them to be a senior, which is this row, and not attending, which is right here. So a senior who is not attending is that 37. And then it's still out of the whole school. Okay. The last phrase is, what is the probability that a randomly selected student will be attending? So the key thing is here is attending. Attending is that 119. So I'm going to do 119 out of 220. Okay. Then for the second part of notes, we have complementary events and calculating odds. So some things we need to know about probability. Probability is never negative. It's never greater than 1 because we turn 100% into a decimal. When an event can't occur, its probability is 0. When an event is certain to occur, the probability is 1. So an example of something not occurring is, I had one and then I lost it. So I'm recording this video on a Saturday, so the probability of me having to go to work tomorrow on a Sunday is 0. I never have to work on Sundays because my schedule is always Monday through Friday because I teach at a school. When an event is certain to occur, the probability is 1. So an example of this would be the sun is going to set today. It's definitely going to happen. Probability is 1. If you add all your probabilities together, so if I'm going back to the ones we were doing over here. So if I had probability of landing on heads, it's 1/2. Probability of landing on tails is also 1/2. If I add those together, it will give me a whole. All of my probabilities added together all add up to 1. And then for any event that doesn't occur, we notate it with this notation. You might also see it with a C for complementary. Means the same thing. We take 1 and we subtract the probability of the event we do know. So if an event doesn't occur, it's either notated in one of these two things. Okay. So on number 1, it says, in the next 32 trials on the docket in the county court, 5 are homicides, 12 are drug offenses, and 6 are homicides, and 9 are property crimes. If the jurors are assigned to trials randomly, what is the probability that a juror won't be given a homicide case? So I know the probability of getting a homicide case is 5 out of 32. So what I want to do is I want to have 1 minus 5/32. If I type this into my calculator, 1 minus 5/32. It gets me this decimal. I turn it back into a fraction. I get 27/32. So another way I could have done this, I'm just going to show the other way in red. I know I had 32 total 5 I didn't want out of 32 total, which would also give me the 27 over 32. On number 2, it says this card is randomly drawn from a standard deck of 52 cards. What's the probability the card is not a heart? There are 13 hearts in there, so I'm going to do this the second way. So I'm going to do 52 minus 13 divided by 52. 52 minus 13 is 39. 39 over 52, and then I want to simplify. Which gives me 3/4. So 3/4 of the cards are not a heart. Okay. If the probability of an event happening is 36 over 47, what's the probability of it not happening? So I'm going to take the bottom number, 47 minus 36 over 47, which gets me 11 over 47. Okay. Number 4 is the same group of students that were polled about prom, but also shows data for sophomores. Typically, sophomores cannot go to prom unless a junior or senior asks them. So not very many sophomores are planning on attending. But the question here is asking, what is the probability that the student was not a junior? So what I'm going to look for is that they are a junior, because I don't want to add all these things up. So there was 106 students who were a junior, 316 total students, and then I need to divide by the total again. So 316 minus 106 is 210, divided by 316, and then I want to simplify this. Which turns into 105 over 158. Okay. Then there's also, when we're talking about probability, is the phrase odds. What we do is the number on top of the fraction is the chance it will happen. The number on the bottom is not out of the whole, it's the chance of the not happening. So for example, if I was talking about the odds of flipping heads on a coin, it would be 1 to 1, because one chance is heads, one chance is not. Okay. So if I take a look on number 5, it wants me to find the odds in favor of getting an ace. There are 4 aces in a deck. Okay. And then I want to do things that are not an ace. So 52 minus 4 goes on the bottom. So I have 4 over 48, because there are 48 other cards in the deck that are not an ace. This simplifies to 1 over 12. Okay, odds against getting an ace. So there's 2 things. I can flip this, or I can do it the other way around again. I could say, I know there are 52 cards, 4 of them are aces, I don't want those, and I do want those in this case. And I don't want the 4 on the bottom, which would give me 48 over 4. When I'm talking about odds, I leave the denominator. Because it's not telling me I have a 12% chance getting it. It's telling me I have a 12 to 1. Okay. Number 6 is telling me the probability of getting exactly 1 pair in a 5-card poker hand is 0.0423. I want to find the odds in favor of getting it and the odds against. So in favor, I know that I want the 0.423. On the bottom, I'm going to do 1 minus 0.423 since I'm working with decimals. Then I'm going to do 1 minus 1 minus 0.423, which gives me 0.0577. Okay, and then I just divide this on my calculator to see if it will write it in a nice fraction. It does, kind of, it gets rid of the decimals. So I get 423 over 577. And then my odds against, I can spell the word against. So I'm not going to do the math again. I know 0.577 is against, and I know 0.423 is in favor. So then I just flip it, and I have 577 over 423 for my odds against. Okay. If I'm given odds and I want to turn it into a probability, I take the number that's given to me first, and then I divide by the number and the against part added together. So on number 7, it's telling me the odds of dying due to an injury at some point in your life are 10 to 237. Find the probability that you will die from an injury. So what you do is you take 10, that's the probability of dying from an injury, and I have it over 10 plus 237. Then I want to add the 10 and 237 to get 247. And that doesn't simplify, so I leave it like that.